group that's on the left side today. So what we call measures of central location. This is mean, median, mode. We're going to do percentiles tomorrow, quartiles today. These are measures of center. So like, where is the data concentrated? That's what those are going to tell you, different ways to measure the center of the data. And then what we're gonna do a couple of these today, but we're gonna focus on a couple more days on measures of what they call variability. So range, in this IQR stands for interquartile range. We're gonna talk about that today. You probably don't know that one. Variance, standard deviation. These are measures of spread. So like how spread out is your data? Is your data all kind of in one area, or is it all over the place? Those are going to be numbers that are going to help us determine the spread of the data. So all these already have a little definition. I'm going to put a little symbol in mean, but mean is just another name for the average of the data set. You guys will see this next week, but this little symbol, and I tried to put it kind of throughout the notes and the homework, the way you would read this is, they call it X bar. It looks like it's a lowercase x, and it looks like it has a line segment symbol over it. That is the symbol for the mean or the average of your data set. This is going to become a little bit more important when we use our calculator to calculate that, but that's what that symbol stands for. That's the mean. The median, middle value, we're going to calculate that in a second for this data set to see that you know how to do it. Mode, I was always told this is the most often. Now, in a data set, you can have no mode at all. You maybe have one mode. You could maybe have multiple modes. It depends on the data set. So we'll get into that when we actually have some examples. And then the range of a data set. So range, not like range on a graph, not like possible y values on a graph. Range for a data set is just going to be your maximum data value minus the minimum data value, and that's going to give you the range, or what numbers does your data span. All right, so we're just going to start this here really quick with a little tiny data set, and these are just average water temperatures in Pensacola, Florida from January to December. So we have all 12 months displayed here. There's 12 data pieces. Does anybody know, or do you remember kind of the process? How would you find the mean or the average? Like, what would you do with those numbers to find the average? Remember? Okay, she says multiply them all together and divide by 12. You're so close to being right. There's one word I would change with that. You just add them all together. So I'm going to grab my calculator. I know there's 12 of them because there's 12 months. All right, so we're just going to do 56, 58, 63, just adding these up. And if you have a graphing calculator, I always kind of try and go back and make sure I don't type any of the numbers wrong. If I can see them all in the screen, that's kind of helpful. And so we're just adding to do the mean, just adding. All right, so the total, let me give you guys a little symbol. You don't need to know this. Does anybody know what that symbol is? Do what? It is a Greek letter for sure. This is sigma. Yeah, for sure. This is sigma. Okay, now in math, if you see this, it means the sum. All right? So the sum of my data values is going to be 860, and then I'm going to divide, that's my sum, just in case, so you see the symbol, don't freak out by it. So sum of all those data values, and we'll just divide it by 12, because that's how many data values we have. All right, now, you guys can see I did not get the nicest of numbers, so if we don't get a nice number, let's just do 2 decimal places for this unit. All right, so I'm going to do 71.67 there. So the average water temperature is about 71.7. Okay, now how do I find the median? Does anybody remember the process for finding the median? Do you remember? Exactly. Okay. Now, when you find a median, you got to put them in order from least to greatest. And I promise this is the only data set that I did not already do that for you. So I am going to put these from least to greatest. So let's just go through the list real quick. So the smallest number there looks like 56. And I'm just going to kind of cross them out so I don't use the same one twice. I see 2 58s. And I see, let's see, 63. 65, 71, just putting these in order from least to greatest, 74, 78, 82, and I got 84, 85, 86. All right, so I used all the data values, we just put them in order. Okay, now, you can do this however you want, and you can do like a couple at once if you want to. I'm going to grab some different colors here today. And I'm actually going to use this data set for describing what we're going to do below here. So give yourself just a tiny bit of space. But I'm just going to start and just one on either end. Or you could, like if you want to do 2 at a time, you could do that too. I just do 1 at a time. And if you have an even number of data values, which we do, we have 12 here, when I get to the middle, there's actually 2 numbers there. So do you know what to do from that point? Yes, you actually, if there's 2, if you have an odd data set, odd number of data values, it will be one of the values. If you have an even number, what we're going to do is just find the average of these 2. So I'm just literally going to do 71, 74, divide by 2, and right in the middle here, this would be 72.5. So that's going to be my median. All right, what would you tell me for the mode, or does it have a mode? Caroline, what do you think? Right. Does this one have one? Yes. Okay, I have 58 twice. All the other numbers are, none of the other numbers, actually, I should say, are repeated. So 58's the mode. If they were all different, you maybe don't have a mode, and you can put that if you get a question like that. Or maybe, let's say I had 2 58s and like 2 86s. You could have 2 modes. You could have 3 modes. The number of repeated times, that would make your mode. Now, for the range, all we got to do, and this would be nice because we already ordered these from least to greatest, but we're just going to take the biggest data value, which is 86, subtract the smallest data value, which is 56, and so the range of all the different temperatures we have there is 30. Is anybody having a question? Okay. Now, we're going to talk about quartiles, and look like when I just ask you guys about it that maybe you're not super familiar with these. So a quartile is basically dividing our data set into 3 equal pieces. And you're going to be like, oh, Miss Grody, there's only 3 of them. How does that divide into 4 equal pieces? So I'm going to show you in a second, but let me just give you these definitions here first. So what we call the first quartile, just be like a capital Q with a little subscript 1. Sometimes this is also called the lower quartile. Like if you were to look this up online or something, lower quartile and first quartile are interchangeable. I would say more often you're going to see first quartile. But what this is the median. Similar process to what we just did to the median above. This is the median of the lower half of the data. The median of the lower half, so like the left side of the median of the data. Now, Q2, also called the median, we already calculated that for that data set. That's right there. So median is just what we just calculated, but that is also the second quartile. That doesn't have a different name, just second quartile or median is what they would call that. And then the third quartile, this is also sometimes called the upper quartile. It's a little Q with a 3 for subscript, and almost an identical definition to the first quartile, but this is going to say median of the upper half of the data. And I'm just going to use that data set right there so we can just do a little example. Okay, so how this works, we have the median, so we already have the second quartile. To get the other two, if you have an even number of data values, which I do in this lovely example here, when you do the first quartile, if your median is like this, I'm going to kind of draw like a little, and you don't have to draw a bracket, this is probably not appropriate, I don't know, but I'm going to find the median of the left side of the median. So I'm going to find the median of just the left side of that data set. It would include the 71 as you do this. That's like on that far edge. So when I'm just going to go through, just cross it out just like I did. And it just depends on how many data values you have here, but this is really similar to what we just did. I'm going to get an average here because I've got 2 data values in the middle. So I'm going to take the 58, 63, add them up, divide by 2. And what is that? Okay, so this is 60.5. I can't read my calculator screen. 60.5. So this would be your first quartile or Q1, just as an example. Now, again, if you have an even data set, you literally just split down the middle those 2 numbers we averaged, and the third quartile, I'm going to do that same process, but just for the numbers on the right side, but you would include the 74. So just cross them off, and I end up 2 numbers in the middle there. This will be a little bit easier to do the average. Just add those 2 guys up. 83 is going to be right in the middle. So 83 would be your Q3. So if it's an even data set, you might have to take an average, but that's how you would do that by hand. We'll do this a little bit later on the calculator. Okay, now what we call the 5-number summary is used to do what we're going to do at the very bottom, which is draw a box and whiskers plot. But your 5-number summary, you have whatever your minimum data value is, whatever your Q1 is, whatever your Q2, also called the median, your Q3, and then your maximum. It's your 5-number summary. That's going to be used to draw a box and whiskers plot. I'm going to sketch you a little example of that in 1 second. Before we do that, I'm going to give you one more vocab term, and it's called the interquartile range, usually abbreviated IQR, so you don't have to write all that out. All you have to do to find it is you take the third quartile minus the first quartile. And I'm going to draw you a picture at the bottom of what a box and whiskers plot looks like. Okay, so I'm going to draw just, you can actually do this, it's totally your choice. I usually use a dot, but you could make like a little tiny line segment. If you wanted to do that, it's up to you. But that's going to be your minimum value. And then I'm just going to draw a little, just like a little line coming out of it. And I'm going to draw a little rectangle. And then I'm going to purposely draw a rectangle that's connected to this, but like a little bit different size, because usually the 2 rectangles are not the same size. And then I'm going to draw another little line with a dot at the end of it. That dot at the end would be the maximum value. Okay, now here's how this works. This first line, this would be whatever your Q1 is, so your first quartile. The line that's inside the 2 rectangles there, this would be your median or your Q2. That would be this line. And your Q3 is going to be the end of the box here. And the reason these are called quartiles when you draw this, what you have, they call the 2 little line segments here, they call these whiskers, and then they call the rectangles box, so it's called a box and whiskers plot. The way this works is 25% of your data is represented between the minimum and where you first get to that first quartile. 25% of your data will be between the first quartile and the second quartile. 25% will be between quartile 2 and quartile 3, or the median and the upper quartile. And then 25% of your data will be between the third quartile and the maximum. So that's your 4, because I got 5 different things here, but we have 4 pieces that each represent 25%. And then just before I flip, just to give you a little visual. So between the 2 sides of the rectangle, that would be your inner quartile range, just between those 2. And that would be 50% of the data. And we're going to draw some box and whiskers plots here on the back in a second. Is anybody having a question? Okay. Now, that little data set we just worked with had an even number of data values. So this data set has an odd number of data values. So I want to just work through how do we calculate the quartiles for an odd number. These are already in order, so you don't have to organize anything. They're in order from least to greatest. And this just says ages of people in a book club. So I'm just going to start, and let me find the median first. So, well, actually, tell you what, we can write the minimum and maximum just looking at the data set. You got 22 and 52. Smallest number, biggest number. We can just write that super quick from looking at the data. Everything else we got to kind of draw on this a little bit to figure out our medians and our quartiles. So I'm just crossing these guys out till I get to the middle. If you have an odd number in your data set, then your median is going to be one of the data values. So that's the case for this example here. So the 40, this is your median or your second quartile, so that's 40. All right, now, what is different between an even data set and an odd data set here with your number of values? You do not include the 40, like this does not get included when you calculate the first and the third quartile. So if your data value, or if your median is a data value, you exclude that. So my first quartile would just be the median strictly of the left side of that data value, and your third quartile or your upper quartile is strictly the right side of that data value. It's not included in either one. So the 40 is not part of that process. So am I going to go back here? Let me cross these out. Oh, and this is actually a nice value here. So on the left side, that's the lower half of the data. That's your Q1, your first quartile. And then on the right side, this is actually a data value here. This is your Q3 or your upper quartile. So I'm just going to record those, and then we're going to try and draw a little box and whiskers plot. So this is 37, this is 47. And just kind of do your best to estimate. This little number line that we're going to put this on goes by 2s. So my minimum value is 22, so I'm just going to, and you can draw this however you want, I'm just going to kind of come above the little number line, and I'm going to draw a dot. Now, I'm going to have to estimate 37 and 47 on here because those are both odd numbers. So 37 would be just the best you can, kind of like a little vertical line between 36 and 38. Now, you absolutely don't have to do this, but if you want to, sometimes these will be labeled like that. You might see a little 37 by the bar, just so you could see it. Not always. The median is 40. The third quartile, I'm going to have to estimate that. That's 47. So I'm just going to do my best to draw a vertical line between the 47 and the 48. And for the maximum, that's just going to be a dot, or like I said, if you want to draw like a little line, you can see another example of a box and whiskers plot underneath here where they just use like a little line segment instead of a dot. That's totally up to you. But I'm going to put that with the 52. All right, and then I just connect my little vertical lines, make a rectangle, and then you just draw a line connecting your minimum and maximum kind of to the box. It doesn't have to be directly in the center or perfect or anything like that, but just that general shape, what we're looking for. Is Anybody having a question? Okay, now I'm going to give you one, and you're just going to answer some questions. So tell me from this box plot, this says this is representing test scores for a certain class period. And now you can kind of see the spread of the data over that course of that number line. Tell me the lowest score somebody got on this test. 55. All right. Tell me, what number would you tell me is the first quartile? 70. These are not meant to be on weird numbers. Just like whatever number you think it is, go with that. What would you tell me the median is, or the second quartile? 75, good job. All right, what about the third quartile? 85. And what was the highest score somebody got on the test? Perfect. All right, now I'm just going to write this in. You don't have to write it, but just to remind you. Now, 25% of the test scores in this class are going to be between the 50 and the 70. 25, I'm going to sneak that in there, 25% of the class between 70 and 75. 25% between 75 and 85. And then 25% of the class, their scores are between 85 and 100. Okay, so see if you can tell me what percentage of this class scored above a 75 on the test? 50%. That's all I gotta do. This would be 50%. Okay. What percentage of this class scored below a 70? 25. Good deal. Can you tell me what the average test score for the class would be from the box plot? That's what you would guess, and is the median necessarily the mean, though? This is super true. That's why I put this on here. Unless you had a list of all the data values, the median is in the middle, but it's not necessarily going to be the average. So I would say just in general, unless you have the data in front of you, you cannot determine a mean or an average just from a box plot. You would have to have the data because the median and the mean are not necessarily the same. So you got to have data to figure that out. You could probably say it's around 75, but you can't necessarily give the exact average. So that's really tricky. That's not something you can pick off of a box plot. Okay, now what I have in the last example here, this is called a double box plot. So I have actually here the number lines kind of across the top, and then this gives you average temperatures in the city of Boston and the city of Seattle. And we're going to just kind of compare these. So this one's nice because they have weird numbers, but they actually give you the number for each of the numbers in the 5-number summary. So you'll not have to guess and kind of compare that to the number line. So let me run through. I'll just put down for Boston. So the Boston is closer to the number line. So the range would just be from 29 to 74. So we would just, excuse me, subtract those. So what is that, 45? The maximum temperature there is 74, the minimum 29, median 51.5, your first quartile 36.5, your third quartile 66.5, and then the IQR interquartile range. We really just kind of mentioned this on the front, so I'm going to just remind you. This is the third quartile minus the first quartile. And I'll give you guys that little formula. It's actually up on the board, so just in case you forget. So for that, from 36.5 to 66.5, the interquartile range, that would be 30. Okay, now, see if you guys can do this. Just write on that information for Seattle, and then we'll just answer a couple questions at the bottom. So just see if you can figure those out real quick. From the graph. The range you'll have to calculate, and the interquartile range you'll have to calculate, because those are not going to be on the box plot. And then if you're done, if you feel like it, there's a couple questions there at the bottom. If you want to see if you can answer those questions on your own. I just wrote them down real quick. Did anybody get anything different than what I just put up there? Is anybody having a question? Okay. This one says at the bottom here, what percentage of Seattle, so that's the one that's at the bottom, what percentage of their monthly temperatures are under 52 degrees? What percentage? Remember, each quartile represents 25% of the data. So what percent of Seattle's are under 52 degrees? 50, right? Because you got 25, 25 up to the 52. This would be 20. Oh my gosh, 50%. Sorry. All right. What percentage of the Boston temperatures, so that one's closer to the number line, are over 66.5? 25. All right, now this is going to give you a percentage and ask you about a city. So it says 75% of the monthly average temperatures are above 45 degrees for which city? This one is Seattle. Is anybody having a question? Okay. All I've got for you guys for the